All right, let's get right into it. We're about to unpack what might just be the single most important invention of the 20th century. Seriously, it's a story about pure genius, brute force engineering, and a legacy that is so complicated it literally fuels both life and death. This is the story of how we figured out how to make bread from thin air.
So imagine this for a second. The one thing you need to grow food is all around us, everywhere, in every single breath you take. But it's locked away in a chemical vault, totally out of reach. For pretty much all of human history, that wasn't a what if. It was the reality that put a hard cap on how many people could live on this planet. And here's just how big that puzzle is. Our atmosphere is a whopping 78% nitrogen gas. You'd think, with that much of it just floating around, our crops would have everything they could possibly need, right? Well, they don't. They're literally starving for it. So, why?
Well, it all comes down to something called the nitrogen paradox. You see, that N2 molecule is held together by one of the strongest bonds in all of nature, a triple bond. It is incredibly stable, which means it just doesn't want to react with, well, anything. It's basically inert. So even though plants are swimming in nitrogen, they just can't use it. They need it in a fixed form, something like ammonia. So the mission was clear. Find a way to break that unbelievably strong bond and turn the nitrogen in the air into something plants could actually eat. And this is where the story shifts from the farm to the lab, into a few brilliant minds who decided to take on what seemed like an impossible problem. Let's meet two of our key players. On the left, you've got Fritz Haber, the Nobel Prize-winning chemist who was the brains behind the whole idea, and on the right, Alwin Mitasch. He was the guy at the chemical company BASF who led this monumental, almost obsessive search for the one special ingredient that could make Haber's theory a reality. We'll get to the third guy, Haber Bosch, in just a little bit. And this right here is what they were trying to do. It looks so simple on paper, doesn't it? You just take one molecule of nitrogen from the air, you grab 3 molecules of hydrogen, and boom, you get 2 molecules of ammonia. And ammonia is the magic ingredient. It's the foundation for all synthetic fertilizer. But, and this is the huge but, while that equation looks neat and tidy, making it actually happen is anything but. The laws of chemistry were basically fighting them every step of the way. To force these molecules to react, they had to create conditions that back then were just totally extreme, almost unimaginable. First up, you needed incredible heat. We're talking 450 degrees Celsius. To put that in perspective, that's hot enough to melt lead. You need that kind of raw energy just to start cracking open those stubborn nitrogen triple bonds.
Second, you needed insane pressure. 200 times the normal atmospheric pressure. Try to picture the crushing force 2 kilometers deep in the ocean. That's the kind of pressure it takes to physically squeeze these molecules close enough to react. And finally, there was the secret sauce. Because even with all that heat and all that pressure, the reaction was painfully, uselessly slow. They needed a catalyst, some substance that could speed the whole thing up. So, Alwin Mitasch's team started this massive hunt. They tested over 2,500 different substances before they finally found the winner, a special iron catalyst. Okay, so Haber and Mitasch cracked the chemistry. That's amazing. But making a few drops of ammonia in a tiny lab is one thing. Producing it by the thousands of tons, well, that's a completely different beast. This next step required a whole new kind of genius, an industrial one. And this was the man for that job, Haber Bosch. He was the engineer at BASF, whose task was to take Haber's delicate, high-pressure experiment and somehow scale it up into a gigantic, roaring industrial plant. His problems weren't so much about chemistry anymore. They were about physics, steel, and brute force. And Bosch hit a wall almost immediately, a huge, catastrophic wall. Under all that heat and pressure, the hydrogen was literally attacking the steel of the reactors, making them brittle. So brittle, in fact, that they would just burst apart after only 80 hours of use. The whole project was about to be a complete failure. So what did he do? Well, his solution was just brilliant. Since he couldn't find a single type of steel that could handle the job, he invented a whole new kind of reactor. He designed a reactor with 2 layers, a strong outer wall for the pressure and a soft iron liner inside. Any hydrogen that got through the liner would just vent out through these tiny channels, which became known as Bosch holes. It was an absolutely incredible feat of engineering that saved the entire project.
So with the industrial process finally figured out, Its impact on the world was immediate, and it was huge. But this is where the story takes a dark turn. Because this invention wasn't just a story of creation, it was a double-edged sword, right from the very beginning. You see, the exact same ammonia that you use to make fertilizer is also the key ingredient for making explosives. The first big plant went online in 1913. A year later, World War I breaks out, and a British naval blockade cuts off Germany's supply of nitrates for munitions. Well, guess what? The Haber Bosch process let Germany keep making bombs. It literally provided both the bread to feed the people and the bombs for the war. So, fast forward 100 years, what does this process have to do with us, right now, today? The short answer? Pretty much everything. Its legacy is woven into the very fabric of our modern world. Every single year, this process is used to make over 90 million metric tons of nitrogen fertilizer. It's estimated that the nitrogen in the bodies of half the people alive today came from this process. Just let that sink in for a second. Without it, our planet simply could not feed its current population. Period. But here's the catch. The nitrogen comes from the air for free, but the hydrogen, that mostly comes from natural gas. This means the entire process uses a massive amount of energy, and it directly links the price of the food on your table to the global price of oil and gas. This became painfully obvious back in the 1973 oil crisis, when energy prices went through the roof, and suddenly, so did fertilizer prices, showing just how fragile our food system really is. And that leaves us with this massive question for our time. We have a process that is absolutely essential for feeding billions, but it's also responsible for about 1 to 2% of the world's entire energy use, not to mention a lot of carbon emissions. So what do we do? How do we feed the future sustainably? The legacy of Haber and Bosch is just one of profound contradiction. It's an invention that saved billions from starvation, but also prolonged a world war and fundamentally changed our planet. The search that they started all those years ago for a better way to do this, well, it continues today, as we're now desperately searching for a way to keep making bread from air, but without paying such a heavy price for it.